But that brings us to the materials we're testing today. We have, what do you guys think this is? Hot Cheetos, hot cheese puffs, or whatever you guys call them. Marshmallows, and then peanuts. So before you guys write your hypothesis, I want to tell you guys a little bit about each of these things. Let's start with peanuts. A lot of people think that they fall under the vegetable group because they come from plants, but in reality, they're really high in protein. So they're grouped oftentimes with meat and milk. So keep that in mind when you make your hypothesis. This is high in proteins. Marshmallows are basically just pure what? Sugar. So carbohydrates. Keep that in mind when you make your hypothesis. And hot Cheetos and most types of chips are made out of it's not pure corn though. It's processed cornmeal, which means they take corn, they do a lot of things to it. They add a lot of things to it like sugar, salt, and different seasoning, as you guys can see. Yeah, there's actually sugar in here. So I want you guys to keep that in mind as well. Okay, one more thing I want to tell you guys about each of these things before you make your hypothesis as to which one has the most energy. The marshmallow weighs, surprisingly this one weighs the most out of these three, approximately 8 grams. Okay? And you can tell the size is generally bigger than the other two. Peanuts, on average, each one's going to be about half a gram, okay, because they're really small. And last but not least, the hot Cheetos are about 2 grams each. So keep that in mind as well. So your next step, go ahead and make your hypothesis in an if-then statement. So if I set these 3 on fire, then blank will have the most energy. Okay, so I'll give you guys, say 2 minutes to form that hypothesis. Okay, by show of hands, I want everyone to raise their hand when I mention the food that you choose, or chose. Who thinks the marshmallow is going to contain the most energy? Okay, 1, 2, 3. Keep your hands up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 for marshmallow.
Are you going to say that?
Oh, you're going to see experimentally. Even better than me telling you. Okay, peanut. How many of you guys think the peanut? Don't raise your hand more than once. Peanut, raise your hand high. 1, is your hand up?
No.
1, 2, 3, 4, 5 for peanut. Okay, last but not least, if you think the hot Cheeto is going to have the most energy. 1, 2, 3, 4. So that's 18. So that means 3 of you guys didn't raise your hand. So I'm assuming those 3 of you guys, you are unsure. Okay? But you'll find out by the end. Make sure on your DNA that you choose one. Question? Question, you raise your hand?
You said unsure, right?
Yeah. Okay, so by the end of the experiment, you'll have a better idea. Get out your quiz. Before we start the lab, I did want to go over yesterday's quiz, which is important for understanding today's lab. Okay, so the most common, there's 2 things that were most commonly missed. Pretty much every single person in the class got number 1 right. A calorimeter is a device used to measure what? Absorbed or released. Let me ask you guys a question. So we're going to set this food on fire, and we're going to put the can up here. So are we measuring absorption or release of energy?
Absorption.
What's absorbing the
water?
The water in the can is going to absorb the heat. What's releasing the heat though?
The marshmallow.
So it's like an indirect way of seeing how much energy the food has. Okay. Number 2, pretty much everyone got these right. Q represents
Heat.
M represents
Mass.
C represents
Specific heat.
It's changing temperature.
Delta T represents change in temperature. What a lot of you guys, about half of you guys missed was the units. Almost everyone got this one. It's joules, grams, and what's
J over GC.
Don't say J. Say
Joules over gram per.
okay. And then change in temperature. Some people left this one blank.
C.
Degrees Celsius. Okay. Most importantly is this last problem on the quiz. because you're going to have to do that on today's lab. So I'm going to show you guys step by step how to do this one. What's the formula for heat transfer, Destiny?
Q equals, well, yeah, Q equals MC times delta T.
Okay, yeah, so I put it on your quiz, but you still had to know how to apply this. Which of these variables were we solving for? Asa?
Delta T.
Delta T. Today, which variable are you going to be solving for?
The C.
Not C, we're going to know the specific heat of water. Q, the heat coming from
The food.
the food being absorbed by the
Can of water.
can of water, okay? So let's plug in our values. How much heat was added?
100.
So 100 joules. What was the mass, let's see, of water? 5 grams. What was the specific heat of the water?
4.184.
Okay, on the quiz, what did I tell you guys to do though?
4 T.
So round off to 4 joules, grams, degrees Celsius. On today's lab, I don't want you guys to round off the specific heat of water. You guys are going to be allowed to use calculators. Is that clear?
Yeah.
Okay, so use the entire value. Last but not least, what goes here?
Delta T.
So how do I isolate delta T? What do I need to do?
By dividing the M and C.
Not multiply.
You can divide.
You have to divide. So what do you divide?
100 by 5 times 4.
100 divided by 5 times 4. What's 100 divided by 20?
5.
So delta T, let me use a better marker. Delta T equals
5
5 what?
degrees Celsius.
Is this value positive or negative?
Positive.
So what happened? Did the temperature increase or decrease?
Increase.
It increased. Okay, very good. Questions on this before we move on to the actual lab? Okay. So I'm going to go ahead. Let's get the lab started as soon as possible because we're going to need the entire period. First thing we're going to do, we're going to read the introduction, and I'm going to let you guys break up into groups. Clear your desks. All you guys need is something to write with and a calculator. If you don't have a calculator, your phone will do.
Oh, okay.
Yeah, you don't need a scientific calculator. Yeah, eyes and ears up here. Gary, your attention. Okay, can I get a volunteer to read the title and the first paragraph of the introduction? Chelsea.
Determining the heat content of snack foods. Introduction. The food we eat provides us with materials to build new cells, tissues, and organs, but it also provides us with energy. Our body metabolizes our food and stores the energy as ATP, which undergoes exothermic decomposition reaction.
Okay, pause right there. How do we know this, before even doing this experiment, how do we know this is an exothermic reaction? Someone who run. You can feel the heat. If you touch the can after each trial, how's it going to feel? Hot. And exothermic reactions do what with heat?
Release.
They release heat. Thank you. Chelsea, go ahead and continue.
These reactions power our body's activity. There are different kinds of energy: heat energy, electrical energy, chemical energy, kinetic energy. The energy in your food is chemical energy and cannot be measured directly, but we can change the chemical energy into heat energy by setting food on fire and measuring the heat given off by the burning food.
Okay, thank you. Can I get another volunteer? Second paragraph. Someone new. I think you've already volunteered. Destiny.
Energy can be measured in calories. A calorie is the amount of heat it takes to raise the temperature of 1 gram of water by 1 degree Celsius. 1 degree Celsius. 1 calorie equals 1,000 calories. In this lab, you will be constructing a crude calorie meter. You will ignite your food samples and hold an aluminum can of water above them as they burn. Heat released by the burning fluid will be absorbed by the water and increase its temperature. By measuring how much the temperature increased, we can get an idea of how many calories were in each food sample. The heat released by the fiery food is approximately equal to the heat gained by the water.
Okay, perfect. When we've talked about that formula, Q equals MC delta T, how have we measured heat in what unit?
Joules.
That's temperature.
Joules.
Joules. Okay, but when you guys look at food containers, how do we measure food energy?
Calories.
Calories. So the first part of this experiment, you're going to measure the temperature change. The next part of the experiment, you're going to figure out the joules, the heat that was absorbed by the water. And then there's going to be a question where you're going to convert into the more common unit of calories. And in order to do that, 1 joule equals 0.239 calories. So all you need to do is multiply your joules by 0.239 and you'll convert it to calories. Is that clear? Question?
I'm kind of confused. It says 1,000 calories equals 1 calorie.
Yes. So another thing that food companies don't always tell you, food labels are measured in kilocalories. And kilo, that prefix means what?
1,000.
1,000. So every time you look at food labels, it's actually in big C's or kilocalories. So what you're converting to is regular calories. And I'm also going to ask you how many kilocalories does each food have.
So for example, if it's 3 big C calories, that means it's 3,000 calories, kilocalories?
Say it one more time.
So if it's 3 big C calories,
It's 3,000 little calories. Yeah. And just to put it into perspective, I've read in a textbook before that 1 regular calorie is about how much energy it takes to power 1 heartbeat. If that helps put it into perspective. Okay.
so
So
calorie.
one little calorie is about the energy it takes to power 1 heartbeat. If that puts it into perspective. Yeah. Let's keep going. Because we need to use all the time for the lab. Let's see. Okay, at this point, I'm gonna let you guys self-select your groups. You guys are all grown or mature enough. So, groups of 2 to 3. There's 8 stations. Once you guys are in your stations, I want you guys to go over the procedures. Once you guys can explain to me the actual lab, I'll give you guys your materials. And before you move, I have a few tips for you guys. Number 1, okay, use the paper clip. Each group is going to be given a cup that has matches and paper clips in them. You're going to use the paper clip to actually skewer the food. Based on past experience, this is one of the toughest parts of the lab. This and lighting the food. Why is it important to keep it elevated if possible, the food that is? Amanda.
So the flame can go up into the can.
Well, that's going to happen regardless because heat rises. But what do all combustion reactions need? Well, yeah, they need activation energy, but air, what's in air? Oxygen. So by keeping it off the ground, it's going to burn more thoroughly. However, you can't really do this to the peanut, so that's one of the limitations of this lab. The peanut, you're just going to place foil on the base of your ring stand, and you're going to burn it directly on the foil. Is that clear?
Yes.
So that's the first tip. Use the skewer for the marshmallow and the hot Cheeto. Use the foil for the peanut. Question?
I was saying we elevated with the foil.
That's true too. But then that doesn't allow the oxygen inside.
Oh.
You see? Next hint. You're going to be measuring out 100 milliliters of water to put into your can. If this does not lead to appreciable temperature change, I want you to redo it using 50 milliliters. Okay, so if the temperature change is not significant enough for you to observe it, decrease the amount of water, but note that in your calculations. Okay, does that make sense? Just the water, the mass of the water. Okay. What else? And here's the easy way of doing an experiment so that you don't burn yourself. Remember I told you guys you can lower it once the food is lit? What's the dangerous thing about doing that? You could burn your hand. So a better way to do it is to have the ring already low. You could light it on fire, and once it's on fire, your can already has water in it, just put this on top. Does that make sense?
Yes, sir.
So you don't have to adjust this, just start it off low. Make sense?
Yeah.
Okay, I think we're ready to go. So groups of 2 to 3, and then once you're ready, come up with your group. I'll give you your materials.